All right, so welcome to another video. We're talking about chi-squared test for independence, and I'm going to overview what the test is used for and then demonstrate this in SPSS. I'm going to use the point and click menus, and then I'm going to talk about the syntax. So first of all, inferential test refers to the idea that we're going to make an inference about a population based on a sample, a collection of sample data. This is a non-parametric test, so we are not relying on assumptions of normality. And what we're going to do is we're going to look at the relationship between two categorical variables. And it's all about evaluating if the variables are related in some way based on the frequency. So that's why we're talking about categorical variables. And we're going to do that by comparing what we would expect to find if there was no relationship and what we actually will find in the cells of the table. So when we do a chi-square, there's a couple things you want to keep in mind. It's appropriate when you have two categorical variables. You cannot use this for measurements that are not categorical. And then the sample here is randomly selected. And then there are a minimum of five observations expected in the cells. So the challenge with this idea is that, of course, truly random sampling is very challenging and not always possible. So there are times where we might use this test, but we have to acknowledge the limitations of not having a random sample. But I'm going to focus on actually doing the test in SPSS and then interpreting it. So before I go into SPSS, just a reminder that our variables are gender and education that we're talking about. I'm using the Machiavellianism, the same old good old Machiavellianism dataset that I pulled from Kaggle that has 500 responses. So we're looking at gender and education again. And we're going to start by talking about hypotheses. So the null hypothesis is the way to think about it is its idea of the status quo, that nothing's happening. And in this case, our hypothesis would be that gender and education are not related in the population, meaning that we would not expect to see a difference in gender by education level or a difference in education level by gender. Our alternative hypothesis is, by contrast, the opposite. And it's the expectation that gender and education are related, and that at some level, we're going to see that there are different proportions of gender and education based on the other variable. So this alternative hypothesis is typically what you are trying to find support for in your research. And we are talking about statistical significance. That's what inferential tests do, is they give us a statistical significance based on our p-value. I have additional videos on p-values, separate videos, so if you need a refresher on that, check that out. I'm going to go ahead and move into SPSS, and again, I'm using our deeply beloved Oporto. So here we are with gender and education. We can see that they're both categorical variables. And what we're going to look at is, again, we want to look at this relationship between them. So I'm going to go to Analyze, and I'm going to go to our descriptive statistics. I'm going to go to crosstabs, and I'm going to start just by looking at the table. So a cross tabulation that I talked about in the previous video. You might also hear it referred to as a contingency table, but I think more frequently I hear it as crosstabs or cross tabulation. So we're looking at gender and education. So my previous example, I had used religion. So I'm just going to leave this as is, except I want to go to my cells and I'm going to identify, I'd like to use my column total, my column percentages. And if you don't know what I'm talking about, go back and look at the last video. So here you can see that this column represents our male responses, and it's broken down by education. So 58 men had less than high school for education. 173 men go away, double click, were in high school or had high school level of education. 108 men had a university degree, 44 men had a graduate degree. And so those percentages, 15.1, 45.2, 28.2, 11.5, they are out of the total number of men, which is this 383, and that's 100% of men. Now I could do the same for female, for other, and then total would be that total in the data set, 66 people had less than high school, 223 people had high school level of education, 147 university degree, 55 graduate degree. And that total is 491 of our 500 person data set. So when I'm talking about cells, I'm talking about one of these where we have the values of one variable dependent on the values of the other variable. So what I want to know is what I'm looking at with my cross tabular or with my chi-square, and it's chi, not chi, chi-square. So here we can look at the distribution of percentages across these different columns. So for less than high school, we have a higher percentage of men who had less than high school than a percentage of women who had less than high school. The percentage of high school degrees is actually very close. We don't see a big difference here, except that other is 100% of the responses. But we can see the total is 45.4%, so this is really similar. Here, we have a higher percentage of women with a university degree. And here it's about the same for graduate degree between men and women, a little bit higher for men. I'm kind of ignoring this other column, which I normally wouldn't do just because there's only 2 people in it. And so that doesn't give us a lot of information. Now, what I would look at right away is I would say, I don't have 5 people in each cell. I didn't have a very representative sample here. So this is not appropriate. It would not be appropriate for me to do a chi-square analysis and make an inference about the population. I'm still going to calculate it just to demonstrate this, but I do want to emphasize that you would not then say, I found a significant difference and this applies to the population. And of course, it's not a random sample, so that's also important. But I just want to refresh you on what we're looking at. So what I want to do with my chi-square is determine, is this difference in high school level based on gender, is it statistically significant? Is it a big enough difference that we can say we think that this actually represents a difference in the population? So let's go ahead and go back. I'm going to go back to Analyze, Descriptive Statistics, crosstabs, and I'm going to go to my statistics and I'm going to calculate a chi-square. Continue. And okay. So here I have the same information, but now I have a chi-square test. And you can see that I'm looking at a Pearson chi-square. I have an actual chi-square value here, my degrees of freedom. And then this is my significance. This is a 2-sided test, is 0.23. So notice that it says 4 cells have expected count less than 5. The minimum expected count is 0.22. So this is a problem. We don't have enough cells that match this, that have an expected count that's big enough to fill this. So this is, again, not a valid test. You would not report this information. But because it is greater than 0.05, we would fail to reject our null hypothesis. We would say that we did not find any evidence that this indicates a real difference between, or a real relationship between these variables. So I'm going to go ahead and go back to my slideshow and show you how you would write this out in APA style if you were to report on this, which we would not because it is not a valid test. So instead you would say that this violates the assumptions of the test. So we did not conduct a chi-square. So I'm going to resume that other screen. So our interpretation of this, how we write this out in APA, you have your chi-squared and you should have this in italics. Our degrees of freedom is 6. That's the way you get degrees of freedom for chi-squares. It's the number of your first variable groups minus 1 times the number of your second variable groups minus 1, which equals 6. You put the sample size there. This is important because you can potentially get a very high chi-square value, and knowing the sample size is important. So our chi-square value is 8.12. Our p-value, and the p is in italics, equals 0.23. So this is not significant. And so this Drake is helping me illustrate, we do not say prove the null hypothesis, we're going to fail to reject the null hypothesis. And again, this is not a valid test based on the assumptions that we've violated. I just want to demonstrate this idea for you with the data set that I've been using for these videos. So again, this idea of chi-square, the purpose is that we're comparing the frequencies in each of our variable groups, so each of our levels of 2 variables, and seeing if there's a dependence between them. So we talk about the chi-square test of independence, but you'll hear dependence, relationship, lots of different ways that people might talk about it. So that's the end of this video, and then we will continue to talk about more analyses in the future.